This video is about equivalent fractions. The word equivalent is a fancy math word for a very simple idea. It actually might sound kind of familiar to you. Equivalent. Right, equal. Equivalent and equal actually mean the same thing. Today we're going to be talking about equivalent fractions. Equivalent fractions are fractions that look different but actually show the same amount of stuff. That sounds kind of weird. So let's think about what that means. We know that 60 minutes and 1 hour actually show the same amount of time. If 60 minutes goes by, that's the same as if 1 hour goes by. So 60 minutes is equivalent to 1 hour, even though we say it with different words, minutes, hour, but we mean the same amount of time. Similarly, we know that 10 pennies is the same as 1 dime. It's the same amount of money. So 10 pennies are equivalent to 1 dime. They're both worth 10 cents. Now, when I look at 10 pennies, they don't look like 1 dime, but I know that they both equal 10 cents. Fractions can be the same way. Two fractions can look different, but actually mean the same amount. Let's see how this works. Once again, I'm hungry for a snack, and I'm going to have a piece of chocolate. I decided to break my chocolate bar into 2 pieces, and I'm going to eat one of those 2 pieces. So I'm going to have 1/2 of my chocolate bar. Just as I was about to start eating, Mrs. Allen walked into my classroom and said, that sounds like a great idea. I have a chocolate bar too. So here you can see my chocolate bar on top and Mrs. Allen's chocolate bar down below. What's interesting is, even though mine is broken into 2 pieces and hers has 4 pieces, if I pull hers up on top of mine, I can see that they are actually the exact same size. They're the same width. They're the same height. They fit exactly. So our whole chocolate bars are the exact same size. Well, I decided to have 1 piece of my chocolate bar, so I'm eating 1/2. Mrs. Allen was thinking about eating 1 piece of her chocolate bar. Since her bar is broken into 4 pieces, eating one of those pieces would mean eating 1/4. But wait a minute. That means Mrs. Allen doesn't get as much chocolate as I get. That's not fair. When I pull her chocolate piece on top of mine, I can see, hey, it's a lot smaller than my piece. So Mrs. Allen and I were thinking, I wonder if there's a way for her to eat more chocolate so that she could have the same amount of chocolate that I get to eat. Well, here's 1 piece, but there's a whole bunch of extra space over here. I wonder what would happen if she ate a 2nd piece of chocolate. If I line that up just next door, look at that. It fits perfectly. It's the same width. It's the same height. It perfectly covers my 1/2. So, if Mrs. Allen wants to eat the same amount of chocolate as I'm going to have, she could have 2 of her 4 pieces, and she would have the same amount of chocolate. That means that 1/2 of my bar is equal to or equivalent to 2/4 of her bar. Let's look at another situation. While Mrs. Allen and I were talking about our chocolate bars, Mrs. Thompson and Mrs. Otto were talking about pie. Oh goodness, do those teachers love pie. And lucky for them, for Teacher Appreciation Week, they each got a pie. Mrs. Otto got a delicious pumpkin pie, and Mrs. Thompson got a delicious pecan pie. And what I notice about these pies is that they are exactly the same size. The pecan pie and the pumpkin pie, when they're still as a whole, are exactly the same size. So, Mrs. Thompson decided to have one piece of her pie. That's the piece she's going to have. And I notice that if I nudge these apart a little bit, her pie is split into 1, 2, 3 equal pieces. So Mrs. Thompson is going to have 1/3 of her pie. Mrs. Otto looked at that pie and said, "Oh, I think I'm going to have a piece of my pie too." So she pulled out one piece of her pie. That piece does not look the same. Mrs. Otto gets less pie than Mrs. Thompson. Look. I'm going to pull it forward. There we go. It's smaller. Well, when I nudge these pieces apart, what I notice is that Mrs. Otto's pie is split into 1, 2, 3, 4, 5, 6 pieces. And if she only eats one piece, she'll have 1/6 of her pie. But Mrs. Otto said, "That is not fair. I want more pie. I want the same amount of pie as Mrs. Thompson has. That's the only fair way." So they lined their two pieces together and they thought, I wonder if Mrs. Otto could have the same amount of pie if she ate one more piece. Sorry, it froze on me. There we go. Look at that. They line up perfectly. So instead of eating only 1/6 of her pie, Mrs. Otto is going to eat 2 of the 6 pieces of her pie. This shows me that 2 smaller pieces are the same as one bigger piece. They're equivalent. So 1/3 of a pie is equal to 2/6 of a pie. 1/3 is equivalent to 2/6. For today's activity on Seesaw, you're going to use the fraction strips, which you received in the supply pickup. If for some reason you no longer have those fraction strips, your teacher will be sending an email with an attachment that has a fresh strip document. You can print that out and then cut out your own fraction strips, which is what I did right here. So, for today's activity, you're going to try to find sets of fractions that are equivalent. You might decide to start with 1/2. You can really start with any fraction you want, but then you need to find 2 or 3 or 4 other fractions that will make an equivalent fraction. So if I start with 1/2 and then I try to use thirds, I'm going to find out very quickly, it's either too small or too big. That does not work, so I won't use thirds. But maybe I'll try 1/6. If I line up my 1/6 right underneath as carefully as I can see that I can make it exactly the same size, right? They're both the same width. So this tells me that 1/2 equals 3/6. It's the same amount of paper in both situations. You're going to take your own sets of fractions and see what you can find to match. Are there any other fractions that equal 1/2? Or maybe you'll decide, hey, I want to try 1/4. Are there any fractions that equal 1/4? 1/6 is too small. 2/6 is too big. That won't work. I wonder if there's another fraction that could equal 1/4. You'll have to play around with the pieces and see what you can find. For each set of fractions that you find that are equivalent, take a picture. Then you'll post those pictures to Seesaw and make sure to write the fraction with an equal sign in between. So you'll have a picture and an equation. There will be an example on the first slide of Seesaw so you'll know what we're looking for. All right, have fun finding your equivalent fractions.